there. Now, another major contributor to the WebGL working group is Intel. They're doing some tremendous work, and so I'd like to invite up Yang Gu, who's the engineering manager at Intel. Please come. And he's going to tell you what they've been contributing to. All right, so let me delete this for you. Yeah, 5 minutes. So you're down there.
Oh, okay.
Ready? And so you can, ready?
Okay. So where's this? This one. Thanks again. My name is Yang Gu. I'm an software engineering manager from Intel Web team. Today I'd like to take this chance to introduce you our efforts on the web graphics. So before diving into the details of efforts from our team, I'd like to introduce a bit of our team. So we have been focusing on web for more than 6 years, and we implemented WebGL 2 in Chrome from the very beginning together with Google. And currently our focus is on WebGL 2 compute, and we contributed lots of patches into the Chromium and its related projects. So currently, we are now the Intel reps of Khronos WebGL working group and the W3C Web GPU community group. Now let me introduce our efforts one by one. The first is about the WebGL 2 compute. This is to bring the OpenGL ES 3.1 features, where the most important feature is compute shader to the web. We have made it almost ready for both the OpenGL backend and the D3 backend for the compute shader. And currently, the TensorFlow.js can base on it and run smoothly. And as our plan, we will try to implement all the compute shader related features by the end of this year. Shader compilation has been a long headache for the WebGL developers. So we implemented some extensions. These extensions can make the shader compilation in the background and in parallel. We have some exciting data here. As the next step, we will further parallelize the shader translation inside the Angle project so that your main thread will never be blocked again. We also try to do some optimization for 360 video, and we are optimizing the video uploads to the WebGL. The patch is still in progress, but we will try to finish it as soon as possible. We are also trying to bring the geometry shader to the web, and currently we have finished the OpenGL backend for it, and we are working on the D3D backend. As to the web GPU, I think you know it, and it's definitely the future of web graphics. This is to bring the advanced native APIs such as Metal, D3D12, and Vulkan to the web. Our journey with this web GPU has begun. As to machine learning, this is a quite hot topic recently, right? Actually, there are two approaches here. One is based on our compute shader solution. The other is based on some OS vendor provided native APIs. Currently, we are working with these OS vendors and browser vendors to define these APIs. And we have a plan to create a W3C CG to move things forward. When we are doing web for web, we will often ask the question, how to compare the web performance with the native? Our answer to that is to port the ACRM, the de facto WebGL benchmark, to the native. Currently, its OpenGL backend can work well with on the Windows, Mac OS, and Linux. And we also did some performance optimizations at the native side. Our plan is to port it to more backends, including both the WebGL and the native. We have been long acting as the quality gatekeeper on web graphics on Intel platforms. With our continuous support, Google helped to integrate Intel platforms into Chrome billboards, and our driver team also integrated the WebGL conformance test suite into the continuous integration system. We also have the monthly conformance and performance test, so we can further ensure the quality here. Finally, I want to call for your feedback. Your feedback, especially on the compute shader, geometry shader, ES 3.1 features, and machine learning, are especially precious and valuable for us. We want to prioritize our tasks and resources based on your feedback. Thank you.